lab for VXLAN EVPN deployment. In this diagram, we have two data centers, DC1 and DC2. In DC1, we basically have two parts, part 1 and part 2, in a multi-part data center. So we'll focus DC1 in this video. The multi-parts in the environment is a single overlay domain with an end-to-end encapsulation, and we build a hierarchy in the topology, and it's a flattened overlay domain. The part 1 is AS number 100, the part 2 is AS number 110. Then gradually we'll move on to the multi-site setup. On the right side, we have DC2, and we are built a super spine in the middle, AS number 777, to bridge the two data center. We are bridging the two control panels in data center 1 and DC2, different MP, BGP, EVPN. But after all in this video, let's do some basic VX EVPN deployment. First, what we'll do is the underlay. So in this video, I will configure basically IP connections, direct connection, all working states. First, what I will do, I'll enable feature OSPF, and then router OSPF. On DC spine 1, we have a loopback interface for name is 111. Loopback in OSPF, we'll say 1, root ID 1.1.1.1, and into loopback 0, or IP OS router OSPF 1 area 0. And I show IPOS interface breakthrough enabled already. Now just type it again and loopback 1 IP router OS PF1 area 0. Then after that, I will enable feature PIM. We'll make a interface loop back 0, IP ping, sparse mode, and loopback 1, IP ping, sparse mode. I'll enable E2, 3, IP ping, sparse mode. Then I know we're gonna choose show run. We can make a loopback 1 as our RP for pin address, IP pin RP address 101.1. Next, let's move on to my leaf 1, similar feature OSPF, router OSPF 1, router ID 2.2.2.2, interface E/1, IP router OSPF 1 area 0, feature PIM interface loopback 0, IP pin sparse mode, and E1 IP pin sparse mode, IP pin RP address 100.1.1.1. Then I will show IPOS neighbor, show IP pin neighbor. They are established. Then after that, so move to leaves 2. We'll go similarly, feature OSPF, router OSPF 1, router ID 3, Aruba 0, IP router OSPF1, area 0, IP router OSPF1, area 0, feature PIM interface loopback 0, IP PIM sparse mode, IP PIM sparse mode, show IP OSPIN neighbor, show IP PIN neighbor, IP PIN, IP address 100.1.1.1. Then let's move to my part 2 spine. Feature OSPF, router OSPF1, router ID 21, 21, 21, 21, and if it's router OSPF1, router ID 21, 21, 21, 21, into Aruba 0, IP router OSPF1, area 0, interface E12, IP router OSPF1, area 0, interface 11, IP router OSPF1, area 0. Show IP OSPF neighbor, show IP pin neighbor. We have one neighbor to the spine and pin to leaf. Leaf will have done that, so I just won't repeat it anymore. I'm going to show you our IP OSPF neighbor, show IP pin neighbor. Now the underlay has been IGP and the PIM for multicast have been completed. So what we have here is the underlay, and now we're going to build our overlay. So first of all, enable is the go back to DC spine 1 and enable NV overlay EVPN. It is to enable VXLAN EVPN control plane, and I'll also enable BGP. So router BGP 100. First neighbor will be leaf 1, 2.2.2, remote AS 100, update switch loop back 0, address family L2 VPN, EVPN. This address family is to have a MAC to VTAP mapping. Instead, we're using IP routes, we're using MAC to VTAP mapping. And what we'll send a community, and we'll send a computer extended. The extended community has the RT values, and it sends MAC to VTAP, IP to VTAP tables. For example, the routes type 2 includes all of them, right? So, and don't forget the spine is also a R client, right? DC1 leaf 1 is very similar. We're going to enable NV overlay EVPN, and we're just going to enable this command for VXLAN control panel. Is EVPN, and we're going to turn on feature BGP, feature VN segmentation, feature VN segmentation VLAN based is to enable VLAN based VXLAN mapping. I'm going to enable feature VN overlay to enable the VXLAN, and we're going to also router BGP 100 neighbor is 1.1.1 or span 1 and remote AS 100, update source, loopback 0, address family L2, VPN, EVPN. We're gonna send community extended. After a while, show BGP sessions. Our sessions to the neighbor spine is established, and it's gonna be our EVPN neighbor. So show BGP L2 VPN EVPN summary. The neighbor to spine for VPN is established for control panel. Also, let's move on to our leaf 2 MV overlay EVPN feature BGP feature BN feature MV overlay router BGP 100 neighbor 1.1.1.1 and remote AS is 100 IGP update source loopback 0. We're gonna enable the VPN L2 VPN EVPN address family is mapped to VTAP mapping table BGP updates EVPN send community extended show BGP sessions show BGP EVPN L2 show BGP L2 EVPN summary. The neighbor to spine for EVPN is established. So next we'll move on to our part 2 spine. The part 2 spine will enable MV overlay EVPN for the control panel, feature BGP router BGP difference AS number 110 neighbor to the leaf remote AS number is 110 update source loopback 0 address family L2 VPN EVPN send community. We're gonna send community extended for VTAP IP map, MAC VTAP map, and route. We're gonna become a RR route refactor, right? This spine to spine and no BGP connection. Now we shall move to part 2 leaf. We're gonna enable MV overlay EVPN feature BGP feature MV segmentation VN segmentation based feature MV overlay. I'm going to say router BGP 110 router ID 22222222 and neighbor is 21212121. Remote AS 110 update sort loopback 0 address family L2 VPN EVPN. We're gonna send community. We're gonna send community extended. That's it. Show BGP session. The part 2 leaf has a BGP connection to this part 2 spine. Show BGP L2 VPN EVPN summary. It's going to have a EVPN neighborship to the part 2 spine. Let's move on to the next big thing. We're going to enable VXLAN on all the leaves. Still, let's open up DC leaf 2. First feature will enable inter VLAN. That's to enable SVI interface. And we're going to enable a big thing, that's fabric forwarding. We're going to make a anycast MAC address, anycast gateway MAC address. We'll say 000, no 2222, no 3333. It will consistent within the control plane. So we're going to create a VLAN. VLAN 100, name is L2 VNI1, VN segment VN segment 10100, and will be the VLAN 110. I'm gonna give a name L2 VNI2 VN. We're gonna segment 10110. I'm gonna have the 111. Name is L3 VNI. We're gonna VN 11111. It will be L3 VNI. Next thing, we're going to enable ARP suppression, but we're going to increase the TCAM table for ARP access. List TCAM for which table. We're gonna let's decrease the VPC to 0, and we're just gonna say hardware access TCAM region. We're gonna increase our ARP table to 254K. Okay, remember to reboot your switch after that, and we're gonna enable the VIF content. We're gonna enable a tenant, and tenant name tenant 1. VNI is 11111. RD will be auto. Address family IPv4. Unicast. Route target both auto. Route target both auto EVPN. That is for our 3 VNI. Exit. We're going to interface VLAN 100. No shutdown. VIF member. Member will be the tenant 1. IP address 192.168.1.254/24. We'll make a fabric forwarding mode, and will become an anycast gateway VNI. Next, VLAN 110, no shutdown. VIF, same thing. IP address 192.168.1.254/24, and it's gonna become a fabric anycast gateway. What we do next for our interface, VLAN 111. Remember, it is the L3 VNI, no shutdown. VIF also is a tenant 1, no IP redirects. And IP forward is going to forward the L2 VNI to L2 VNI for routing. L3 layer 3 VNI just use to forward, so there's no IP needed in this. Well, so next we're going to create an interface for NVE1 interface. No shutdown is interface that used for encapsulate and decapsulate the VXLAN packets, right? So no shutdown, host reachability, we're gonna do protocol BGP. Is use BGP EVPN control panel. We're gonna use this for BGP EVPN control panel. And the south interface loopback is gonna be 0. Member, first member, BNI 10100 MCAST. For this, we're gonna 225.1.1. It's BNI 10100 is the VNI in my pot in my DC. So member, next member VNI 10110 MCAST 225.1.1.11. Exited. Member VNI 11111 associated VIF. It's for our L3 VNI. Next thing, what we'll do is we're going to enable EVPN is to define L2 VNI RD and RT or making bridging in the same VNI. So with VNI 10100 L2 and RD also we're going to define that within the VNI route target both L2 VNI 10110 L2 RD auto route target both auto. Now we completed all the VXLAN configuration. We're going to enable the /2 for the endpoint interface. We're going to switch mode, switch port, mode, access VLAN 100, no shutdown, switch mode, access VLAN 100, switch port, access VLAN 100, no shutdown. That's all the configuration we require to configure on the leaf. And we're going to repeat all this configuration on all the leaves in DC1. Let's move on to leaf 2. Into feature interface VLAN, fabric, forwarding, and cast gateway MAC 000, 2222, 3333, VLAN 100, name L2 VNI1, VLAN 110, name L2 VNI2, VN segment 10110, VLAN 100, VN segment 10100, VLAN 111, name is L3 VNI, VN segmentation 11111, and we're going to increase TCAM table, hardware, access list, TCAM region, change VPC convergency to 0K, hardware, access, TCAM region, ARP is 256K. Don't forget to reboot your switch. So VIF content Telnet 0-1 VNI 11111 RD auto address family IPv4 unicast router get both auto route target both auto EVPN. Remember my L3 VNI needs to route RT for EVPN. Interface VLAN 100, no shutdown. VIF member is tenant1, IP address 922.168.1.254/24. It's going to be VXLAN forwarding mode Anycast gateway. It's going to be Anycast gateway. Interface VLAN 110, no shutdown. VIF member going to be tenant1, IP address 92.68.1.254/24. This is going to be fabric forwarding and cast gateway. Last one is interface VLAN 111, no shutdown. VIF member, it's going to be tenant1, no IP redirect. IP forward is a L2 VNI to VNI for routing, L3 VNI just for forward, so we don't need an IP. I'm going to repeat all that. All the next is the interface MVE1. We're going to enable in-cap and decap VXLAN, no shutdown. Host reachability protocol is BGP. Source loopback 0. First member VNI 10100 MCAST 225.1.1.1. Next VNI member 10110 MCAST. We're using different multicast group 225.1.1.11. Last member is VNI 111.11. L3 VNI is just going to associate the VIF for L3 VNI, and we're going to enable EVPN VNI 10100 L2 RD auto route target both auto. I'm going to give it the RDRT to my L2 VNI. Similarly, VNI 10110 L2 RD auto route target both auto. That's it, and we are gonna move on to give 1/3 VLAN 100. Gonna to interface Ethernet 103 switch mode, switch port mode access, switch access VLAN 100, no shut. The last one will be our part 2 leaf. We're going to feature interface VLAN, feature fabric forwarding and cast gateway 0002222 VLAN, create a VLAN for 100. We're going to be a L2 VNI1. We're going to assign VN 10100 VLAN 100, name L2 VNI2. VN segmentation is 10110. Don't forget my L3 VNI. Name is gonna be L3 VNI. VN segmentation is 111.1.1. We're gonna decrease tcamp for BPC to 0K. Tcamp region will going to be VPC to 0. Hardware is access. Tcamp region. We're going to increase the ARP Ethernet to 256K. And then we're going to reboot the switch. After that, so we're going to create the VRF. Going to become 10 net 1. VNI is 111, RD auto, address family, IPv4, unicast, route target, most auto. Don't forget EVPN. This is EVPN for the L3 VNI and interface VLAN 100. No shutdown. VRF member is 10 and 1. IP address 192.168.1.254.24. Fabric forward mode Anycast gateway. Interface VLAN 110. Second VNI, no shutdown. VRF member 10 and 1. IP address 192.168.11.254.24. Fabric forwarding mode Anycast gateway. Alright, we have a L2 VNI interface for Anycast gateway and L3 VLAN 111. No shutdown. VRF member is 10 at 1. No IP redirect. IP forward. Next, we'll create the interface MVE1 interface used for decap and incap VXLAN. No shutdown. Host reachability will be protocol BGP. We're using BGP for control plane. Source interface loopback 0. Member VNI 10100. MCAST 225.1.1.11. Next member will be 10110. VNI MCAST multicast. We're going to use 225.1.1.1.11. We're going to change that. The last VNI, going to change different MCAST. And member for VNI 111.11 L3 VNI, just going to associate VNF. For the next, we're going to enable EVPN VNI 10100 L2 RD auto route target. Sorry, no VNI 10100 L2. That's it. RD auto route target, both auto. VNI 10110 L2 RD auto route target, both auto. We're gonna have one client. It's on the E/E1/2. Gonna assign to my VLAN hundreds. Search mode access switch access via band 100, no shutdown. Now we repeated the same configuration VXLAN deployments in the 3 leaves. Now let's pick up our server T1 on our leaf 1. Let's see if we're lucky. See if we could ping it. We're gonna ping is the 192.161.1.111. Yes. We're gonna ping .1.222. Yes, we can successfully ping. Now we go to leaf 2. We're gonna do some show BGPL2 VPN EVPN. Let's see if we can see my client on leaf 2 192.168.1.111. Yes, we have the update for this my own clients on leaf 2. In this entry, I can verify it is a L2 BGP update, and its MAC address of the client server T2 and its IP address right here. Also can verify extend community metrics like RT is going to send RT and RT for the L3 VPN, L3 VNI, or if it show BGP L2 VPN, EVPN, I'm gonna grab the MAC address. Also can see the update, BGP update right here. If I want to go to my pod 2, leave show BGP L2 EVPN, I can see the update also. But I need to do one more ping from my pod 2. Then if I go to my pod 2 leaf, the M2 updates is right here. Then we shall move on to my DC1 leaf 1 will show BGP L2 VPN EVPN VNI ID 10100. What I'm going to see is the VNI updates for the 33/33 host updates with the MAC address and the VTAP IP.